In this lesson, we are going to cover advanced materials. Be sure to have this file open, and let's start an interactive render to check what's going on in the scene. As you can see, the scene appears mostly white. So now we are going to go through the process of setting up and modifying different types of materials. Let's start with the wall. Select it, and then open the Asset Editor and click the Flyout menu to navigate to the material library. As you already know, the library contains hundreds of materials grouped in different categories. However, sometimes you are going to want to modify some of them to better suit your needs. For the wall, let's go to the Wall Paint and Wallpaper section and choose the Stucco J01 color. Then, left-click and drag it into the materials list. Let's go ahead and collapse the library flyout menu for now. With the stucco material selected, I'm going to right-click and choose Apply to Selection. Open the flyout menu to the right, and let's also change its color using the color swatch. I'm going to shift its hue value to a blue-green color and make it slightly darker. As you can see, this wall paint texture is a bit too pronounced. Let's draw a render region over this area of the wall and explore the material. Drop down the reflection menu, and you'll see that the reflection slot is using a texture map. Let's try adjusting the reflection color to a mid-gray value. Notice that it doesn't have any effect on the final result, since the reflection of this material is controlled entirely by the map. You can also see a preview of the map by clicking on the texture icon. Since we want to keep using the map, but also be able to make changes to the reflection color, an easy solution is to blend the map with the color. Scroll down and expand the Multipliers tab, and change the mode from Multiply to Blend Amount. When the Blend Amount mode is selected, texture maps will be blended with the color you choose. Let's now set the reflection color slider to 0.5, so that we are using 50% of both, resulting in a less pronounced wall texture. You can now disable the render region so that we can preview the entire image. Now let's move on to the floor and draw a new region that encompasses it. Open the left flyout menu again to go to the material library, and let's choose a material for it. I'm going to enter the concrete folder and drag the concrete flooring J01 2-meter material into the material list. Now in the viewport, click on the floor object and right-click to apply the material to it. Now let's add some varnish to the floor. To produce this effect, click on the small stack icon with a plus sign on top that is located at the very top of the material options. From here, you can add different sorts of layers on top of the material. For the floor, we are going to add an additional reflection layer. Now, we have a reflection coat layer that is applied directly on top of the material. If you find it too strong, drop down the reflection menu and simply dial down the reflection color. Once you're ready with the floor material, you can again disable the render region and wait for the whole image to clear up. Up until now, we were only modifying already existing materials. Let's take a look at how we can create a brand new material from scratch and how to set up a few types of common materials. First, let's create a simple plastic material for the chair seat. Move the render region on top of it, and let's select it in the viewport. From the Asset Editor, click on the Add Material button, which is the leftmost icon at the bottom, and choose a generic material. This is the standard V-Ray material that can be used to replicate all sorts of different substances, some of which we are going to explore in this lesson. In fact, most of the materials in the library are made of this generic material. Now, apply it to the chair seat and change its name to plastic. Then, pop out the flyout menu to the right and change its diffuse color to something you like. I'm going to set it to a dark gray or black color. A good tip for realism here is to avoid using extreme colors. For example, don't use completely black or white, or 100% saturated colors, as this would take away from the realism of the image. Next, let's introduce some reflections. Under the reflection dropdown, set the reflection color to a mid-gray. Right now, the reflection is also too sharp. You can see that the light reflects off the chair almost like a mirror. Let's lower the reflection glossiness value to 0.75 to blur the reflections a bit more. Most of the time, you'll likely want to keep this value between 0.6 and 1. And that's it for setting up a basic plastic or paint material. Okay, now let's create a slightly more complex material that uses bitmaps. Move the render region over to the buffet or sideboard, and in the materials list, search for a material called wood. It is another generic material, with all of its values set to the default ones, which has already been applied to the cabinet doors. Starting with the diffuse color, click on its texture map slot and pick bitmap from the list. From the assets folder provided with this lesson, choose the wood001 diff file. Right now, the texture looks too large. Since you're already familiar with the process of changing the UV's projection scale, let's explore an alternative method for setting the texture size. Go ahead and expand the texture placement rollout. Here, you'll find some basic options for manipulating the texture, such as offset, rotation, and repetition. Let's set both repeat UV values to 4. Now, the texture scale looks much better. Next, hit back, and let's give the wood material some reflection by increasing the reflection color to a light gray. This time, we are also going to use a texture map for the reflection glossiness. Click on the texture icon, assign a bitmap, and choose the wood001 glossiness file. This will help to create some variety and detail. It's also the same wood texture that we just used for the diffuse component, except with some color manipulations applied to it to use with the reflection glossiness slot. As you can see in the bitmap preview, there are no dark areas in the map, and the colors only range from mid-gray to white. Once again, in the texture placement section, let's set the repeat UV to 4 to match the diffuse texture. Now, we are done with the reflection component. Head back in the material, collapse the reflection settings, and then drop down the Maps menu to add a texture map to the bump slot. Flip the bump normal mapping switch on and assign a bitmap to the slot. Let's select the wood001 bump file, and again set the UV tiling. As you can see, the effect is way too strong, so head back in the material and let's reduce the amount slider to something like 0.07. Now let's disable the render region and preview the entire image. Great! Let's stop the render for now and close the VFB in the asset editor. There are also some hidden objects we should reveal before we proceed. Go to the Layer panel and unhide the Accessories layer. Let's also enable the Named Views panel. You can also dock it under the Layers, as we'll be using it a few times. Next, locate the Hourglass close-up view and double-click to switch to it. Now let's start an interactive render and set up a glass material. Open the Asset Editor and in the Materials list, search to find the material called glass. This is a default generic material that we can use to create a realistic glass material. Draw a render region around the hourglass objects, and then let's set the diffuse color value to pure black. Glass materials usually don't have a diffuse color component since they rely on other properties. Next, let's drop down the reflection menu and set the reflection color to white. Then collapse the reflection menu and let's set the refraction color to pure white to make the material transparent. You can also use the fog color to tint the color of the material. Note that the effect is stronger at the edges and the thicker parts of the object. Let's give it a light blue color. As you can see, the effect is a bit too strong, so let's adjust the fog multiplier value to 0.1 or until you see the color only at the edges. Different materials also refract light differently, depending on their IOR or index of refraction. You can check the internet to find the IOR values for different materials. To be more precise, let's set the IOR to 1.33, as this is the physically correct value for glass. Now, disable the render region, and you can switch back to the render view to see how the material looks. When you're ready, let's head directly over to the record player close-up view. Now, let's draw another region render over the record player. Open the Asset Editor, and in the Materials list, search for a material called Metal. Again, This is a default material that has already been applied to some parts of the record player in advance for this lesson. Now we are going to turn it into a chrome-like metal. This time, we'll want to make the diffuse color almost black. Let's also set the reflection color to pure white, keeping in mind that metals usually get their color from the reflections. Let's also decrease the reflection glossiness to 0.85, which is suitable for a relatively polished material. It still looks like shiny paint though, rather than metal. That's because the IOR value is set far too low. To correct this, first let's make sure Fresnel is checked. All materials exhibit the Fresnel effect, which essentially means that surfaces appear less reflective when facing the camera, and more reflective when they are facing away from the camera. Metals tend to have the same reflection strength though, regardless of the viewing angle. In order to achieve this effect, let's tick the Reflection IOR checkbox and increase the IOR value to 20. You'll see in the render region that the material looks much more like chrome now. Now we can shrink the region a bit so that it only covers the platter of the record player. Sometimes, scratches on the surface of the object give the reflection highlights some direction. This can be simulated with the anisotropy parameter. In the materials list, search for the record player platter material. Note in the reflection dropdown that it already has some glossy reflections. Let's go to the anisotropy rollout, also located in the reflections section. Set the anisotropy value to 0.7. And then in the rotation texture map slot, let's load a gradient map. Then change the type to radial. Now, back in the material, we need to change the local axis to set the correct orientation for the anisotropic effect. In this case, Y works fine. To finish things up, you can also go to the Maps dropdown, turn on the Bump Normal Mapping, and set a map for the scratches. Select Bitmap and choose Scratches Radial.png. Then go back and decrease the amount quite a bit to something like 0.05. Now remove the render region just to check what the record player looks like with the new materials. When you're ready, proceed to the fabric close-up view. Now we are going to look at how we can use displacement to easily generate complex geometry. Let's set the region over the fabric and search to find its material, which you can probably guess is called fabric. Now scroll down to the Maps tab, and underneath the Bump properties, you'll find the displacement properties. Go ahead and switch it on. Now you can choose between two modes, normal and 2D displacement. Let's switch to the latter, as it is really fast and good at preserving texture details. Just keep in mind that it requires valid UVs. Now, click the map and load a bitmap in the texture slot, and select Fabric Displacement from the Assets folder of this lesson. Go back and adjust the displacement amount to something to your liking. I'm going to set the displacement amount to 0.5. You can also set the resolution to match the size of the texture you're using. To add a final touch, you can scroll down to enable the water level option. This clips the geometry in places where the displacement map value is below the water level threshold. You can try some different values. Just make sure that they are below your specified displacement amount. I'll set it to 0.07 so that we have some tiny holes in the knit. Now, turn off the render region, and if you want to, you can also switch back to the render camera view to check what it looks like from a distance. All of the materials we've done so far were of the generic type. Let's take a look at a few others we can utilize in some specific cases. Switch to the paper lamp close-up view and draw a render region around the lamp. Next, go to the light section of the asset editor and turn on the paper light by clicking once on its icon. It is a small V-Ray sphere light located inside the lamp object. As you can see, the light illuminates the inside of the lamp, but no light passes through its surface as we would normally expect with a thin material such as paper. Go to the Materials tab, and this time, create a two-sided material. This is typically used to simulate materials such as paper, leaves, grass, fabrics, and other thin tissue-like items. You'll see that it has a front and a back material. Let's go to the front slot and pick the Paper Lamp B front material. Close the asset editor, and then select the lamp. Note that it doesn't have any thickness. The two-sided material works best with such geometry. Now, back in the asset editor, go ahead and apply the two-sided material to it. Note how some of the light from the inside is now passing through the object. You can use the slider to adjust the translucency, or use a black and white texture for more control. You can also add a material for the back. If this slot is empty, V-Ray will automatically use the front material for the back as well. Let's add a different back material. From the drop-down list, pick Paper Lamp B Back. Now, slide the translucency slider, and note how we are now getting some of the details from the back material blending with the front one, based on the translucency amount. Once you're ready with this material, disable the render region and wait for the image to clean up a bit. We are now going to move to the candles close-up view and look at another type of material that's going to help us create a wax material for the candles. Before we start working on the material, let's select the glass and hide it. Let's also draw a render region around the candles. Now, select the candles and in the asset editor, create a new subsurface scattering material. Apply it to the selection and you're going to notice that they already look much more like they're made of wax. Let's explore this material a bit further. At the top of its settings, you'll find the overall color. You can use this when you want to globally filter the color of the material like so. However, in most cases, you'll want to keep this white. Then there is the diffuse layer. You can typically use it to simulate dust or dirt on the surface. By default, it has no weight at all. You can use the diffuse amount slider to blend between it and the subsurface layer. For our scene, let's keep it at 0. Then there is the subsurface layer. This is the essential part of this material, and it is pretty much all we see in the render region right now. The subsurface color controls the color of the material beneath the surface, while the scatter color controls the color of the scattered light inside the material. Of course, you can use whatever colors you'd like, but the default ones work well for this example. I'm just going to make the subsurface color slightly brighter. With the scatter radius, you can control the amount of light scattered inside the material, which you can observe as I drag the sliders. I'll set this to around 2. The phase function lets you control the direction of the scattered light. Negative values direct it backwards, while positive ones direct it forward. I'll set this to 0.5. There is also a specular layer, which contains the reflection properties of the material, as you can observe when I move the amount slider. You have control over the color, glossiness, and strength. I'll leave these at their default settings here. Finally, let's expand the scattering options. Click on the Single Scatter drop-down menu, and you'll see that you have different options for better simulating particular types of materials. You can use Simple for opaque items such as skin, Ray Traced Solid for highly translucent yet relatively opaque materials such as marble or milk, and Ray Traced Refractive for substances that are highly translucent, allowing you to see through them. Let's switch it to Ray Traced Solid and move on to the next type of material. Move the region over the candle flames and close the frame buffer to select the flames, and then reopen the VFB. In the asset editor, let's create an emissive material and apply it to the flames. This material can be used for things that emit light, such as displays, LEDs, or as in this case, candle flames. Most of the time, you'll just be using the 3 parameters at the top of the emissive settings. To create the candle light, let's change the color to something warmer and then increase the intensity to 1.5. Now let's take a look at some procedural textures and how we can use them to improve some parts of our image. We can also click on the texture map icon and add a gradient. Change the type to V, and then set a middle control point to a dark orange color. Add another control point near the right end. Next, set the rightmost control point to a saturated shade of blue. Lastly, for the leftmost control point, set this tip to a dark red color. Return back to the settings and now add a texture map for the transparency. Let's experiment by adding a gradient ramp to the transparency slot to make the flame more opaque at the center and more transparent towards the tip and at its base. To achieve this, change the type to V and add a control point to the center of the gradient. Make it black. Then, brighten up the leftmost control point like so. Now turn off the render region, and let's return to our render camera to see how the whole scene looks. Next, let's take the wood texture of the buffet or sideboard cabinet and change its color using the Color Corrections node. Go ahead and redraw the render region around the sideboard. Now, go to your materials and locate the wood material we created at the beginning. Let's right-click on the texture map and choose Copy. Then go ahead and click on the map, and then click on the menu icon on the left. Select a color correction map. Now, right-click and paste the texture in the color input slot. Here you have some controls that you can use to manipulate different aspects of the texture, such as its lightness, color, and contrast. Let's scroll to the bottom and decrease the brightness a bit. Be careful though, as the slider is quite sensitive. I'm going to use a value of -0.1. Doing so makes the wood darker, but it also looks more contrasty and saturated. Now we can decrease the contrast to compensate for that. I'm going to set it to around 0.8, and then let's lower the saturation as well. I won't go to extremes here either. -0.29 looks about right. Finally, let's shift the hue slightly to the left to something like -2.6. That sums up all the adjustments for this texture. Another very useful technique is to use a noise map in the bump slot of a material to give the appearance of some surface imperfections. From the named views, let's choose the chair seat close-up view. Create a render region that covers a fair portion of the seat, and in the materials list, find the plastic material we created at the beginning. Under the Maps section, enable the bump map, and then click on the map's texture icon. Let's pick the Noise B texture, although you can use the Noise A for the same purpose, it just has some different parameters. Since this is a 3D texture, we can take advantage of that by scrolling down and toggling on the Use 3D Mapping switch. This way, we won't need to bother with UVs, and the texture will be mapped seamlessly. Since we've applied this texture in the bump slot, we're going to leave the colors to black and white. You can also change the noise type to regular. The other types provide some different patterns, but for this example, the regular one works just fine. Now you can increase its size quite a bit, just to get a better idea of what the noise looks like and what it does to the chair in the preview. Then let's set it to 0.3. The effect is way too strong though overall, so let's go back to the material and decrease the bump amount to something around 0.02. Finally, let's close the asset editor, clear the render region, and switch back to the render camera view to wait until the image cleans up a bit. And there you go, nice work.